Hi everyone, my name is Khalees.
And my name is Roderick.
And today we are going to be teaching you about the monohybrid and dihybrid cross. First, we are going to be discussing a little bit about the man who started it, Gregor Mendel.
Gregor Mendel was a meteorologist who first discovered basic hereditary principles. He created laws like the law of independent assortment and the law of segregation.
Now we are going to be conducting a monohybrid cross. The two alleles that we have is a heterozygous and homozygous recessive gene. The capital T stands for tall and the lowercase t stands for short. And these are the alleles that we are going to be crossing into our Punnett square.
So we will now begin to fill out the information that is needed on the Punnett square. We're going to put the heterozygous gametes on the outside of the square on top, like Khalees is about to show you right now.
So like Roderick said, we now have the heterozygous alleles on top of the Punnett square. And I also did the homozygous recessive alleles and put that on the side of the square. So now that we have this information filled out, we can now begin the crossing method. So these alleles are gonna go this way and these alleles are gonna go this way. So now I'm going to do the crossing method right quick and show you how that would look. So these are the offsprings for these parents. This is the F1 generation, and the genotypic ratio for this would be 2-2, 50% heterozygous and 50% homozygous recessive.
So now that we have an understanding of the monohybrid cross, we can now move forward with the dihybrid cross. Dihybrid crosses are used when two characteristics are involved at a time. So let's use the trait from earlier, height, and let's add the characteristic, color.
So we are going to write the heterozygous gene for the trait height and also the heterozygous gene for the trait color. The color that we will use is yellow. So the genotype for both traits would be dominant T, recessive T, dominant Y, recessive Y. Now the phenotype for that would be a tall and yellow plant. Now we want to cross that with a short and white plant. So the genotype for the next parent would be recessive T, recessive T, recessive Y, making both alleles homozygous recessive.
To get a better understanding, you must get a better concept of Mendel's law of segregation. In a sperm and egg cell, they each only contain half the genetic material, so it makes sense that the gamete can only carry one big T or a little t between.
So if a plant has 4 alleles, then there are 2 genes. That means if a gamete only carries 1 letter per gene, then each gamete will have 2 alleles, one accounting for each trait. This means you have to prepare for every possible combination because according to the law of independent assortment, the alleles are not linked.
So first you're going to write out your parent cross, then you have to find the combinations from the parents and put them along the top of the side of the square using the FOIL method. FOIL stands for first, outside, inside, and last. First you're going to FOIL the TTYY.
So now I'm going to teach you how to do the FOIL method. So as you can see, I already FOILed the second parent, and now I'm going to teach you how to do the first one. So basically we're going to do the first alleles, and that'll give us a dominant T and a dominant Y. Then we have outer, which is the outside alleles, so that gives us dominant T and recessive Y. Then we have inner, which is these two, so we have recessive T and dominant Y. And lastly, we have these two, which is last, and that gives us recessive T and recessive Y. So now we have the combinations from the parents and can place them outside the Punnett square. Now we can combine the gametes to predict all the possible offspring outcomes. For the sake of time, I have already done that. This is what the 16 square Punnett square would look like. And all of these offsprings would be a part of the F2 generation. So now lastly, we're almost done. Trust me, I know it's long. But now all we have to do is find the phenotypic ratio. So for this first column, it would be the tall and yellow plants The second column would be the tall and white plants. This third column would be the short and yellow plants. And then the last column would be our short and white plants. So all in all, our phenotypic ratio is 4, 4, 4, 4. Well, y'all, we have successfully conducted a dihybrid cross and monohybrid cross. I hope you have obtained a well enough understanding of these two things. I know it's very long, but trust me, it's easy once you get the hang of it. I hope you've learned something new today, and have a good day, y'all. Bye.